Hello and welcome to episode 23 of TGI Kubernetes. I'm your host, I'm Joe Beda. I'm the CTO of Heptio, one of the founders of Kubernetes. And with TGI Kubernetes, every week I pick a topic. Sometimes it's a new project, sometimes it's an area of Kubernetes that I want to demonstrate and talk about, and then go deep on that. Usually my goal is to try and keep things under an hour. Sometimes this can go to an hour and a half. Last week was about 2 hours. That was probably a little bit too long. So before we get started, if anybody's watching, if you could go through and let me know in the chat, that would be great. Just to make sure that everything's coming through. All right, great. Parthamon, good to see you. Dimitri from Moscow. You guys are living in the future, so it's probably Friday night, Friday evening for y'all. Liz, how's it going? Good to see you. Liz, it's getting to be quitting time for you soon. Chris, Marco, Stefan, Josh, awesome. All right, everything's looking good. Mike from New Jersey are on. Jason. All right, Tim, good to see y'all. All right. Well, this week is going to be, we're going to be digging into private registries. And so these are going to be publicly hosted private registries, so like a place where you can push your code, your images, and then download them. I'm going to be looking at some of the more popular ones and figuring and then showing you how you can adapt that stuff to run inside of your cluster. And so we're going to be rolling some stuff out. We're going to be pushing some images. We're going to be doing some of that stuff. This is not going to be about how to host your own registry. It's not going to be about self-hosting a registry. I think that'd be fun also. I think that's something that I'd like to explore, but I didn't have enough. I don't think I can make it through all of that in one episode. So maybe I'll do that in a future episode. So yeah, but I'm going to try and keep this stuff down I'm going to try and keep it relatively short and move faster this time because I think last time things went really long. But I do want to give a shout out. So let's see. So where did I leave off? So we have Saul from St. Paul. Let's see, somebody who just hit the keyboard with their forehead. Salvador, Yapeng, good to see you. Parthamon, so yeah, on Twitter, like was it yesterday, we all went out for burgers. And so we went from our office here and we took the Seattle Light Rail up to Capitol Hill and got burgers at this place called Dick's. I was wearing the t-shirt a few episodes ago and then made it back and we were able to make that run during our lunch hour. So we posted some pics online, and that's what Parthamon's talking about. So Chris is just on the other side of the office. Lamati, good to see you. Mike, Antoine from Paris. And then Dressel from the Netherlands. So good to see you all. All right. So I usually start off TGIK by going into some detail of some interesting things that have been happening around the community, new projects, new announcements, that type of thing. January, I think, typically ends up being a little bit of a quiet month, so we haven't seen a lot of stuff going on. And but there's a few things that I think are interesting. So let me go through and let me switch to my screen. So the first thing is Applatix. This is the folks that are driving the Argo project that I talked about 2 episodes ago. They were just acquired by Intuit. So that's kind of interesting. Not clear sort of what that means for the Argo project. Obviously when a company gets bought like that, there's always a lot of questions about what that means with respect to their open source commitment and whatnot. That being said, I think it's a really interesting project, and so I'm hoping that regardless of what happens moving forward, the project itself will continue to develop. I know it's something that we're looking at Heptio here to figure out where it may make sense for us to start using the project. So still a super interesting project, but just be aware that the company just got acquired, so I'm sure there's some celebrating, but also some figuring out what that means for the open source project, or at least their commitment to the open source project. Fernando, good to see you. And then the next thing is, so I did, the last week's episode was on Nucleo, which is a serverless platform. Lot going on there. I feel like I only scratched the surface of all the stuff that's going on there. One of the things that I meant to mention last week but forgot to mention is that they were doing they're doing sort of a hackathon contest. There's still 3 days left to submit, so maybe this is your weekend. I don't know. But I just wanted to make sure that folks saw this, that they could get a shout out there to see what's going on. And there's the folks that are going to be judging and stuff. So it looks really interesting. And they're going to be giving away, I don't know, like rules. I think they're going to be given, okay, first place is a Phantom 4 drone. So that's kind of fun. Yeah. All right, Ors from Berlin. Good to see you. And then the other thing that's, I think, interesting is the Nucleus folks turned over a release. So this was released a couple days ago. And some of the stuff actually was smoothing over some of the rough edges, some of the stuff that I stumbled over during the TGIK. And so it's really great to see folks, to see that feedback loop, that they're reactive, that they're listening, and that they really want to improve the project. So that's really exciting also. Just wanted to call out that. Jay Hernandez from Guatemala, welcome. All right. Now this I'm super excited about this. So 99% Invisible is probably my favorite podcast. It's awesome. I learned so much. I'm the type of person that bores people at the party with like fun facts. A lot of them come from 99PI. They actually, like, I have the 2 of the 99PI challenge coins and stuff like that. So if you're into it, like, it's a great podcast. The latest episode is an episode with Scott McCloud, who wrote this Understanding Comics, which is 25 years old. Super interesting. Now, the other thing that Scott did is he did this Smooth Sailing with Kubernetes, this comic that Google commissioned a little while ago. And super cool, this comic. But what's fascinating is that Scott mentions Kubernetes and actually says the word Kubernetes in the podcast, which is, for me, it's like my favorite podcast. Actually mentioning Kubernetes is super, super cool. So so check that out. If I know I've mentioned 99PI in episodes, and there's interesting stuff there that really applies to a whole bunch of domains anytime you're thinking about design. But yeah, so check this out. Super exciting to see Kubernetes mentioned there. So that's the only stuff that I had in terms of what's happening around sort of the Kubersphere this week. Is there anything I missed that you guys would like me to sort of, talk about, think about, take a look at? I don't think I sort of racked my brain and asked a few folks in terms of what am I missing this week, but it seems like it's been a relatively slow week. No? All right. Well, let's jump into it then. Let me go ahead and minimize this. Oh, so Chris is asking, what is Heptio doing? Open census. Oh, the open census stuff is interesting. I didn't look at that deeply. Let me pull that up real quick. So I haven't looked at this deeply, but I've looked at when I was at Google, I knew the systems inside of Google that were actually dealing with this. And one way to think about this is this is an extension of distributed tracing, things like Zipkin and Open tracing, that type of thing. But instead of just looking at your application, this actually takes that all the way down in terms of like, how are you actually dealing with all, well, okay, maybe I'm wrong. So this is so I think this actually goes all the way down to the OS to actually help understand what your OS is doing, I believe, and then pulls that stuff together. I could be wrong. So this is distributed tracing and metrics. Maybe I'm confused. I don't know. Maybe I'm confused here. So I haven't had a chance to sort of really look into this, but it looks super interesting. Because I know Census at Project, at Google actually did go all the way down. And so the fact that that I thought I saw, well, Signal, maybe I'm wrong. So I haven't looked at this. Looks really interesting. Want to dig deeper into this. I don't quite have a positioning this versus things like Zipkin or Open Tracing in my mind. And then Parthenon says cubed shell. I hadn't looked at that one. So cubed, is that? Oh, I hadn't seen this. This looks interesting. Oh, no. Oh, yes. This was Michael Hasenblas at Red Hat. Yeah, he went through and showed this to me. This is really interesting also. So yeah, I should have mentioned this. And so the idea here, and this is something that would be fun to play with, is that it's an interactive shell that feels like you're actually working with Bash, but when you run a command, it actually goes ahead and packages that and runs that in a container. So it's sort of a Kubernetes like a Kubernetes enabled shell to some degree. It's still pretty early days, but there's interesting things like if you go through, and I'm trying to like find the good example, because I think he had a. So he had a GIF that actually showed, GIF. I'll take both. He had one of those that actually showed how it worked. But the idea is that you can feel like you're working locally, but it'll actually sort of spawn stuff across a whole bunch of stuff. And then telepresence, you mentioned that, Yggdrasil. I think, was there something new around telepresence? Was there a new release there? Maybe. So this is another. So there's a really there's an interesting, and I don't have a good mental map of this, and this is something that I meant to actually, I have to find some time to sit down and really play with. But I think that there's probably like half a dozen techniques about how you connect your local machine and your local environment to a Kubernetes cluster. And it could be something like Draft, which is doing builds and pushing. It could be something like telepresence here, which I believe this actually works with a networking proxy. There's like a whole bunch of different techniques there, and I think different techniques work for different types of development environments. And it's something that I think deserves a little bit of sort of breakdown of like what are the different techniques that work best in different situations. So that's something that's really interesting too. But okay, so yeah, so might be fun to do a little demo at one point in the cubed shell, and talk about some of the pros and cons there, which is really interesting. Open census, I need to learn more about. I made some assumptions when I was talking earlier. I think I may be wrong. So I'd like to understand what open census is. And then telepresence. It's been around for a while, but it's one of these things that helps to bridge the gap between your local laptop, and so that's an interesting project also that might be worth digging into at some point. All right, that's enough of my yammering. Silviu from Switzerland, nice to see you. All right, so here's what I have going on here is I have one of our quick start clusters running in Amazon. This is what I've been using for a lot of the TGIKs. We've updated this to 1.9, so this is running on 1.9 right now. One of the things, just if you're interested here, let me bring back this. If you look at Heptio Labs Word Room, this is a tool chain that we created for creating AMIs, and we're using this both for our quick start, but also looking to use this for customers too. So it's a combination of Ansible running sort of in a local mode plus Packer to be able to go ahead and help build images. And so there was a lot of work that went into this over the last couple of weeks as we refreshed the quick start to bring it up to 1.9. So that's also something that we've been working on. So Fernando says there's a playground on Katacoda for cubed shell. I couldn't find it searching for it on Katacoda, but there's a link on the Twitter post from Kubernauts today with the link to it. Okay, so I'll look for that. Maybe I'll include that in the show notes. So that's interesting if there's one of those sort of playgrounds going on there. All right, so by default, when we launch one of these quick start clusters, it runs with the AWS cloud provider integration built in. And so this is the thing that teaches Kubernetes how to automatically create load balancers for you and how to automatically attach and detach EBS volumes and sort of like make persistent volumes work there. Hans from Sweden, good to see you. And then, and one of the other things that it does is it teaches the kubelet how to use the native authentication. So when the kubelet drives Docker, it gives Docker the right configuration so that it'll use the built-in mechanisms for authenticating to the local container registry. So if you're running on GCP, the kubelet knows how to use the right roles, the right things to be able to actually tell Docker to download images GCR. If you're running on ECR, on AWS with the AWS cloud provider, it'll automatically go through and do the right stuff to get the right authentication so that it can then go and actually talk to the Amazon container registry. Yash from India. Wow, you are staying up late and or getting up early. Thanks for joining. 2:45 in the morning there. Wow. All right. So that's really convenient. So typically, if you're running on a cloud and you're using the registry that is sort of paired with that cloud and you have your cloud provider configured correctly, there's a certain amount of it just works and you don't have to think about it because it's sort of handled at the kubelet level. I want to demonstrate this without relying on that. So what I did is I launched one of our quick starts and then I went and hacked the configuration to essentially turn off the AWS integration. So we're going to be working with a cluster that doesn't have any special AWS integrations with it. And the script that I used to do that, let me find it down here, is pretty much what I do is, and I already did this, so I'm not going to do it again, is we have these manifest files in etc Kubernetes manifest. This is when kubeadmin brings up a cluster. It uses this thing called a static pod, which is essentially a pod where the description, instead of coming from the API server, is on disk on that node. And so the API server for the cluster and the controller manager are managed by the kubelet, but that kubelet is getting its marching orders from disk instead of actually getting them from the API server. And so what we can do is we just remove the cloud provider equals AWS parameters. We delete those lines out of the YAML for these two manifests. And the way that this works is as soon as you modify those manifests, the pod gets re-updated with the new parameters. And so as soon as you run these sed commands, it'll restart the API server and the controller manager with those new flags. Meanwhile, with the kubelet itself, it also has a flag. And so what I go through is I have a parallel SSH command line here that'll go out to all the nodes and turn off the cloud provider on all of those and then do the systemd magic to get it to reload the kubelet. So that's already done. So we're not using any of the cloud provider magic here to authenticate to the different clusters. All right. And so the other thing that I want to call out here is that I'm probably going to end up flashing some credentials on the screen. None of these things are easy to remember type keywords, but there's a good chance that somebody who has a quick eye can actually sort of steal some passwords while I'm operating. Please don't. Please be nice, and don't troll me here. It would be very difficult to do something like this without showing some passwords. After the show, I'm going to go through and change and revoke all those credentials. But while we're doing the show, those things will be live. Flying without a net here a little bit, so please be nice. Murat from the Bay Area, good to see you. All right, so we're going to be looking at 4 different registries today. We're going to be looking at Docker Hub. We're going to be looking at the Google Container Registry, the Azure Container Registry, and the AWS ECS registry. I don't even know. Call it ECR for short. And we'll see some of the differences between those. I think it probably makes sense to start with the Docker Hub right now. And so the first thing to keep in mind here is I created an account here called TGI Kubernetes. Let me see. Let me bring my notes up here and see what's going on here, because at Docker Hub. So one thing to keep in mind is that okay, so first of all, terminology, because this confuses the hell out of me and I just want to get this stuff down. A registry is the API that you're talking to be able to store container images. A repository is essentially a set of container images that are related to each other with tags. And so you can think about it as kind of like a container image track, where it's a bunch of container images with different tags. The container image itself is the thing that you actually specify. It contains both the repository plus the tag. You combine that it becomes an identifier for the container image. You can have multiple identifiers for the same container image. With later versions of Docker, there's sort of a cryptographically secure SHA that actually becomes a Merkle tree hash signature of all this stuff. And then built into the container image are a bunch of layers. And so these are really an implementation detail for most users that really help to minimize the amount of push and pull across this stuff. And so you can see here I have my password again. Be nice. Don't steal that. So what we're going to do here is when you're logged into the Docker Hub, okay, Yash says, please overview VMware Harbor. I've never used it. I think that's something worth looking at. I don't think I'm going to have time today. I don't think I'm going to be flashing AWS credentials that'll let you bring up VMs. I don't think I'm going to be that far off the reservation, Chris Murat. Okay, so VMware Harbor I think is interesting. I think there's Quay, there's Artifactory and the JFrog stuff. So there's a whole bunch of sort of other registries here. Hopefully, sort of like as we see some of the different things, there'll be some sort of translatable questions that you can ask and some learnings across this stuff. But unfortunately, I don't think I'm going to have enough time to dig into all the various registries that are out there. All right, so okay, so the Docker Hub is the registry. When you have, let's see, so when you have a personal set of repositories that are prefixed with your name, okay? So this will be TGI Kates/foo : bar, and I can have a whole bunch of there. But that prefix, that TGI Kates thing, I only get one of those prefixes that matches up with my username. So that prefix is actually, it's kind of like the GitHub model. Most closely matches. But in addition, there's organizations that you can create. And when you create organizations, you can give multiple users access to that. And so what you end up with is a drop down here where you can choose, am I operating in the guise of that organization, or am I operating as an individual user? I just created this thing. This is there's nothing else here. And then here you can see the repositories. So so what you do here, and let me go, and I can do Docker log. Okay, so first of all your login information gets stored in Docker config.json. And in fact, I meant to clean all this out. Let me go through and edit this. So what we're going to do is we're going to actually unauth everything. So that's kind of how you do it. And then I'm actually going to clear some stuff out of the keychain off screen here where you guys all can't see it. All right, so this is, so we're going to do Docker login. And what this is going to say is, what is your name? And so by default, when you do Docker login, it's going to actually authenticate you to the Docker Hub. Everything in Docker defaults in a bunch of ways to the Docker solution, but there's ways that you can point it at other registries and such. And you'll see when we start talking about naming things, the Docker names, Docker gets special position, the Docker Hub gets special permissions and assumptions with respect to naming images. All right, so we can go TGI Kates, and then the password, again, super secure. Please don't copy this. We'll do that. And then this is logged in. Oh, wait, and I'm getting this here. And I'll explain what's going on there in a second. Okay, so now I've done this. I'm actually logged into Docker, so now I can push and pull stuff from my Docker registry, from Docker repositories. Now, if I do a cat of this thing, you'll actually see it added this line here. And usually what would happen is where we actually see this empty map in this JSON file, that would actually store your password. But I'm using this cred store thing that stores it in the OSX keychain instead. And so if you look at my keychain here, and I don't know if I can make this any bigger, unfortunately. I don't think I can, because this is probably hard to read. Shoot, I didn't even think about that. Is there a way to zoom? No, I don't know, man. Okay, so there's no way to like make this bigger, is there? Yeah, I don't know. Okay. Well, anyway, so you can see here, this says Docker credentials. If I click on that, you get, and this, and I can say show the password. Oh, and it wants to ask me again, because why not? And then you can actually see the password there. So this is using the the OS keychain, the OSX keychain, to do this. And the way that this works is that you have this JSON file here, and then there's Docker credential OSX keychain, which is an executable that has commands to store, get, erase, list. It essentially becomes the interface to this stuff. So anytime you call Docker, it then in turn calls this to actually store and get the passwords and stuff. And so you can install this. I don't think this is installed by default. I'm really not sure because it was already installed on my machine, and I'm not sure if I did something. You can install it with brew and then add it to your config here, and it actually keeps the credentials out of plain text. Okay, so now we got that going on. One of the other things I have here is you'll see. Oh man, I meant to clear some of this stuff out, but let me do this real quick. RMI. Okay, so Silvio says it says he also has it. Okay, I can push Command Option Plus to zoom in. Whoa, no, that makes it big. That's not what I wanted to do. Like Command Option Command Plus. That didn't work for me. I don't know what to tell you. So. No, that didn't work for me. Okay. Well, we won't muck with that right now. So we're going to do Docker RMI, Docker. I'm just deleting these things so that I can demo stuff. I meant to do this before TGIK, but I screwed up. Okay. So, and we have some stuff there too. Okay. So here I have an image that I've already built, which is QuarD AMD 64 tagged with 1. Command, yeah, it's not working for me. I don't know. We'll figure it out. So David's asking, is there any way to make the AWS registry URLs more friendly? I don't think there is. AWS does like their long opaque identifiers, don't they? But we'll get to that. We'll get to that. Okay, so I have this thing here, and so I've built this locally, and if you go to the QuarD repo, you'll actually see some instructions on how to build. So I've done that. I have this thing. I can go, Docker run. So we can run this locally. It works fine. I can then hit this on like localhost 8080. We're up and running. So I actually have this thing running locally. Everything's great. Now I want to take this image and I want to upload it to the Docker Hub. So I can't, so like if I do Docker images, Docker push this thing, it's going to say, no, can't do that. You're not allowed, right? So what I need to do is I need to actually create an alias to this, and that's by doing tagging. So I can do Docker tag, which says create another name for the same image. And I'm going to tag this thing, QuarD AMD 64 1 2 TGI Kates / QuarD :1. Okay, now if I do Docker images, you can see I now have this one here that says, oh, I've gone ahead and I've tagged this thing, I've given it another name. And then when you push, which says upload it, now it actually knows how to actually call and talk to this thing and upload things. So we just pushed this thing up to the Docker Hub. And you can see that there's a cryptographic hash that actually pulls all that stuff together. Couple interesting things going on here. The name of the image is kind of where you get it. So like the identifier and the location that it gets downloaded from, those things are actually one and the same. Didn't necessarily have to be that way. I think there are ways with to create caches for this stuff, but it's different from, say, other packaging formats like RPMs or debs or something like that, where the name of the RPM or the deb is very different from where you get it, and you can have multiple ways of getting it as long as it actually gets identified. With Docker, by and large, the name of the image is the place that you got it from. All right, so now if we go back to the web browser here and we look at the Docker Hub, and if I go ahead and refresh this. So Sylvia, can you use the signature for validating future downloads? Yeah, you can go through, I believe this tag, they call it a digest, is used for cryptographically identifying stuff. And what you can do here is, let's see, if I do Docker images help, and I do Docker images digests, what you can see here is here's the digest of the thing, right? And so what I can do is I can do Docker, let's do Docker run, and here instead of quard this thing, what I'm going to do is I'm going to do TGI Kubernetes.quard1 quard, and then I'm going to actually specify that I think that works. Or no, I think I have to do an @ sign there. So there's a way to actually say I want to run this image at this particular SHA. Yeah, boom, there you go. So what you can do is you can take that SHA and you can use that as a cryptographically secure way to identify that image from now and forever. So that's one way that you can go through. There's a whole nother system around signing images. I'm not going to go into the detail there. You can actually even use hardware tokens like YubiKeys and stuff like that to sign the images. So will you show how to delete this created repo at the registry? We can look at that later too. So Aaron says, I never understood why I had to locally tag before I push rather than just Docker push to the remote repository. Any insights? You know, I don't understand. I like Aaron, I think in my mind, the name of the image and the thing that's storing and delivering the image, those things should be able to be different. That's just not the decision that Docker, the company, and Docker, the open source project, has made. And that idea that image names and image download locations can diverge is something that has caused a lot of strife in the community. It's one of the big sort of places where there's sort of huge nerd fights between Docker and Red Hat, for example. I believe, and I may get the details wrong here, I believe Red Hat actually carries a fork of Docker that does provide ways to override where you're hitting registries and start to actually split out the name from the location that you download the thing from. All right, so now we got this thing up in here, and we can see that this thing is public. You get one private repository for free. And so what we're going to do here is we're going to actually make this thing private. And so we'll go ahead and do this, and this will use up our one private thing. So now this is a private repository, and we're going to do that just to make sure that we don't accidentally pull the public version of it when we start testing stuff out. And then you can see that if you go into like settings here, you can set what the default is for private versus public. Now you should realize that like Docker Hub pricing, you get one private repository for free. You know, you start paying sort of $7 a month to go all the way up to $100 a month or more. I'm sure if you want more, they'll talk to you and work with you there. But you pay per repository, and that doesn't that works regardless of how many images you put in that repository. I mean, they probably have limits. Technically, you could probably have divergent images all in the same repository, but typically folks don't do that. But so AWS, but Docker Hub charges you per the repository, not based on the amount of space that you're taking in that repository or the amount of download bandwidth or anything like that. So pretty simple pricing model there. So if we go back here, we can see that there's all sorts of information around this. I can see the tags, the size of the thing, you know, you can set up webhooks such that anytime a new image is pushed, it actually sends a webhook and does stuff. So there's a lot of extra features that come with repositories. I'm not going to be digging into a lot of those details right now. So this thing's uploaded. I assume like to delete it, like can I go through and if I go to settings for this thing, I can go ahead and delete the repository here. So if we wanted to get rid of it, that's how we could do. All right, and so now what I can do here is kubectl. Well, let me get the right command line thing here. We'll just go ahead and we're going to do this. So we're going to run image equals, and we're just going to do TGI Kubernetes qrd1. And I went ahead and created this, and this is running, and I do kubectl get pods, and if all goes well, it'll actually give me an error. So it says container creating. Let's do describe pod qrd. Let's see. So it got scheduled, failed to create pod sandbox. So let's see what's going on here. So what's happening here, and this is actually I would expect it a better error, to be honest here. I'm not excited about it. So because we're actually having trouble pulling the image because it's a private image that we're trying to get. And this may be a 1.9 thing. I hadn't seen this before. Failed to create pod sandbox. So we don't actually have a great error here coming from this. And so that's not great. All right, so that's something I might want to look into. Okay, so what we're going to find here is if I go through, let's go through and, well, okay, so this is fine. Andy says, pretty sure it's having an issue related to creating the pause container. It's not a problem with the private image. Maybe, do you think I screwed up the cluster by doing the ACR thing, by removing the, it's not a problem with a private image is what Andy's saying. Okay, let's do a little quick debugging here. We'll take a really quick detour. I don't have a ton of time, but this is like, I might have screwed up my, I have a backup cluster in case I really screwed things up. But if you look at this cluster here, I can go through, I can do SSH command. I can do this. This is happening on and do sudo. Yeah, sudo journal control dash. All right, so what we see here, error syncing pod. Network plugin CNI failed to, oh, etcd clusters. So something's going, okay, so this is probably me screwing up my cluster when I undid the undid the cloud provider stuff. I did that yesterday, and I must have screwed it up because it's having trouble bringing up networking, and that's the error that we're getting here. Hans says, never heard of the pause container before, reading up on it now. Yeah, it's fascinating. The pause container is sort of a hack to sort of make the sort of pod model work with Docker. So yes, this is a CNI issue. So what we're going to do is I am not going to try and fix this here. Let me go through and I'm going to bring up my backup cluster here, and you guys are going to see how I do this stuff. I have my Bastion IP. So I have set up kubeconfig, my Bastion IP I'm going to set here. And my master IP I set here. And then I can do source, setup, kubeconfig. Okay, we don't have that. Now let's do the run. Kubectl describe qrd pod. All right, this is what we expected to see. Yeah, so CNI issue there. I'll debug that later and actually figure stuff out because I'm interested to figure out how I screwed that up because that's actually pretty impressive. I might have edited more stuff than I did with my little sed program there. All right, so what we see here is image pull back off. And this is happening because this pod is running with, it's not able to actually pull the image, right? Because the image is a private image. And this is what we would expect to happen. So now what we're going to do is I have a little script here. And what this does is we're going to create a secret called Docker Hub. And it's going to be a secret of type Docker registry. Okay, so when you create secrets, there's different types of secrets. And really there's 3 that most people are going to deal with. There's Docker registry secrets, which is what we're working with here, which the system has special knowledge on how to use to actually pass to Docker so that Docker can download images. There's TLS secrets that are to be used by things like Ingress. And then there's just generic secrets that you can use for your own purposes. You can create secrets with your own sort of type field to them, and it's a good way to sort of be able to filter stuff. But it's a way to essentially sort of create some type of typing for the secrets. If we had to do this over again, with CRDs, we might instead have a type of CRD, which we call, a secret CRD, that gets special types of treatments, and then maybe Docker registry would be some type of CRD, and the TLS might be another type of CRD, and these are secret CRDs. Just history, we have secrets of different types. But anyway, so what you do is you run this thing, you tell it the server that you want. Oh, darn it. That's not right. I copy and paste. I didn't even try this out. Shoot, TGI Kubernetes. Is that the right password? I think so. Yeah. And then the Docker server, is that, oh shoot, what is the Docker server for this? Kubernetes secret Docker server. I'm going to look it up because I want to make sure I get it right. Okay, so this is index.docker, and this might be the default for the thing too. I don't know. Let's see. I think that's right. What could go wrong, right? So kubectl create secret, and you'll see that here's the 3 different types of secrets. And if I do Docker registry and help, okay, yeah, so it does default to the Docker one, but you need to pass in a password, a username, and then an email. And the email is ignored by everything now. In fact, Docker itself is going to do it, so that's kind of deprecated. But kubectl still expects you to put an email in there, so you have to just put something in there, and it really doesn't matter. So we can remove this line here since this is the default. Okay, so what it's saying is I want to create a Docker secret, and essentially just has my username and password, the same stuff I passed to Docker login. And then you have to do this email here and just put something in there that looks like an email. It's probably kubectl should stop insisting that you need an email because nobody uses it, so it's kind of stupid. So Alex is saying, can the Docker registry secret be used with other container runtimes? I'm not sure. I think that's a good question. My guess is yes. I think everything tries to be somewhat Docker compatible. Andy might know if it works with Cryo or not, if he's listening. All right, so let's go ahead and let's run this thing. Set up Docker secret, and now I can do kubectl get secrets, and we called it Docker Hub. That tells me about YAML, and so we're going to look at this. So let's see. So Andy says, sorry, was fiddling with Jenkins. What was the question? Oh, the question was, can the Docker registry secrets be used with other runtimes like Cryo? Do you know? I'm sure with containerd it can, because containerd is kind of closely related to Docker. Okay, but what we see here is that we have one entry here in this secret. So the secret contains one entry, and then the type of the secret is kubernetes.io/dockerconfig.json. Now, There's actually two different, like historically, there's two different ways that Docker has stored stuff. For like any recent history, it's that file that cat docker config.json, and that's where docker config JSON. See how this lines up. So it's essentially this stanza is, it's one of these things that we're actually encoding in this thing here. So if I take this output here, so and secrets are base64 encoded. So I can do echo to base64-d, and we'll pipe it through JQ. And you'll see what we have here is this looks, again, very similar to this here. So it's that same file that's sitting locally, gets put into a secret with the right format. And then along with this, you have the username, you have the password in plain text, because YOLO, and then we have this special thing here called auth. And I think this is a historical wart also. I don't think that Docker uses it anymore, but maybe previous versions of Docker does. This is a base64 encoded thing also, so double base64 encoded for your pleasure, just for extra safety. We can do that, base64, and you'll see that this is just the username and password concatenated with a colon, and then base64 encoded. I assume again that this is leftover cruft, but there's special code in Kubernetes when it creates these secrets that actually helps to generate that. So now this is sitting there. I have this secret in Kubernetes, but nothing in Kubernetes knows how to use this thing yet. And so there's two different ways that I can tell Kubernetes how to do this. I can attach this to a service account. When I attach it to the service account, if the pod uses that service account, then that secret then gets used for the for pulling images. And then the other thing I can do is I can actually attach this to the pod directly. So let's go ahead and see if we can attach it. I haven't tried this yet. Kubectl get pods. Let's see if we can do kubectl edit pod quar d. This is going to pull up this image. So here's the pod here, and I always have to look up the schema. Oh, here we go. Yeah, I already had this up here. So create a pod. So there's image pull secrets. It's a peer to containers. We'll put this down here. And the secret, what do we call this thing? The secret is called Docker Hub. Okay. And so let's see what happens when we do this and we close this. Now we've essentially, oh, you know what? Darn it. What's going on here? Forbidden. Pod updates may not change fields other than image, init containers image. Oh, so you're not allowed to actually change this on the thing. So I got an error there. So what we're going to do, oh, and it's going to get really mad at me. So what we're going to do is we're going to kubectl delete pod quar d. Let's see. And so run. Does this, I wish this had like an edit option that says, let me edit the YAML before you submit it. I don't think that it does. So we're going to get a little, okay, so we're going to take this, we're going to do dry run YAML. So that actually, dry dash run. Well, I got a lot of warnings. It was really angry with me. All right, so this is essentially the thing that kubectl run is going to submit. So we're going to actually redirect this to quardpod.yaml. We'll go ahead and we'll edit that thing. And it's a lot easier to see because we don't have a lot of the junk that's here either. And this was image pull secrets and then name Docker Hub. All right, so let's go ahead and submit this. Kubectl create -f quardpod.yaml. Boom. Kubectl get pods. All right. Oh, and it's running. Okay. So there we go. So now you saw how that works. What we did is we added the image pull secrets that we wanted to use to the container. You can have a list of these things, and it'll try like to use the right secrets for the right thing. So that if you had like a container where you're pulling like you have pod where you're pulling one container image from one thing and another thing from another thing, and init containers, you can actually integrate multiple registries, private registries across this stuff. So that's cool. That's exciting. All right, so that's how we can do it by editing the pod directly. And that's how we do things with Docker Hub. All right, so that's Docker Hub. Let's do, which one do you all want to do next? Which one should we do next? We can do Amazon, Microsoft, or Google. Give me some feedback here. Which one should I do next? If I don't hear anything, I'm just going to pick something. No? Azure? Suresh wants to do Azure. We got AWS. All right, Suresh got in there first, so we'll do Azure. And then we'll do AWS. And then we'll do Google. All right. So let's start with Azure. So every time Project Atomic's not a registry. We'll do Azure first, and then we'll do AWS. So every time I use the Azure console, I got to be honest, I get really confused. Now, one of the interesting things is that Azure, you have your login. With that login, you have access to these things called subscriptions, which are essentially things that pay the bills. Within that, you can create resource groups. And resource groups are somewhat similar to projects in GCE, but they don't have the same sort of visibility isolation that you have with it. So there's a lot of sort of grouping concepts with Azure that are kind of confusing if you don't spend a ton of time on that. The interesting thing here is that you can create multiple registries. And so these are the things that get named with everything else. So what I have, okay, so first of all, if we start here at the Microsoft Azure dashboard, you can see that like there's like a gazillion services that you got going on here. If you search for registry, you'll see container registries. That's the one that I clicked on here. That comes up, and you can see that I don't have any registry here. Is there an atomic registry? Tim says there really is an atomic registry. Okay, well, my mistake. We're not going to do that today. Maybe some future time I'll do the next round of private registries. But what we can do here is we can do create container registry, and that takes us to this like wizard thing. Now, the other interesting thing about the Microsoft Azure portal is that while everything else on the web scrolls sort of vertically, everything in Azure sort of happens horizontally. So you'll see this as we build some of this stuff out. So we're going to name this one TGI. And what you're going to see here is that this is actually coming out of a global namespace. And so I can, TGI, Kates.azurecr.io. And so you're creating new registries, and the name for these registries that are going to be seen, when you use this stuff is completely disjoint from the name of your account, the name of your company, everything else. So really, you're allocating something out of a new global namespace here. So the subscription that you want, this is that Azure is giving us free credit still because we're a startup. You can use a resource group. I have a resource group around TGIK here. There's a location that this thing's sitting in, which is kind of like the region, if you're used to AWS. We're going to enable the admin user. I'll explain what that is in a second. And then there's this confusing thing here called SKU. SKU stands for Stock Keeping Unit. It's the ID that you give something when you're doing box software and shrink wrapping it. But somehow this applies to container registries. I really don't understand. So Marco says, is this the same thing as your container registry? It is. That's how it's called to me. So you see something different on your screen, Marco? And all this stuff for all these things you can do with the CLI too. So I'm doing this stuff through the console because I think it's more visual. All this stuff can be done with the CLI, and there's tutorials for it and stuff like that. Now the SKUs are confusing. So And the UI is like, this is classic. Like, I'm sorry, I don't want to beat up on Microsoft too much, but I hover over this little eye and I'm like, oh, look, there's this thing up here that says more info on pricing and capabilities. Let me click. Oh, no, can't click on that. Nope, can't click on that. I have to click on this thing, which gives it a dotted outline, which is not centered on and is cut off by the control underneath it. And then I can click on more pricing and info. And then you can see that there's like 3 sort of tiers of service here, with number of webhooks and whether you get geo-replication with it or not. This seems like a lot, but we're just going to stick with standard there. Okay, so we're going to go ahead and create this. Okay, Hans says, been using Azure for K8s and registry for 8 months now and happy with it. Okay, that's good. So I think, it seems like if it's solid, that's great. Once you sort of get, like for all these things, there's going to be little quirks that we'll go through and you can, figure out, once you sort of understand those quirks, I think, all of these options will work well for you. All right, so now we go ahead and we create that. And it takes a second because it's actually doing some stuff here. Anytime you do anything in the Azure console, it does a deployment. Even though we're not deploying software, it's like creating things is kind of like a bundle of things that have to happen, so it's a deployment. So we'll go ahead and hit refresh here. Now you can see we have this TGI Kubernetes thing. And again, you can see this sort of horizontal scrolling going on. And then there's a lot of cool stuff that you can do in the registry. You get like an activity log. You can control who has access, automation, webhooks. So there's a lot of cool stuff here. The thing that we're going to look at here is access keys. And so this is what we're going to need to do to be able to log in from our local thing and actually, our local machine and upload stuff. And one of the things you'll see here is that we have like these passwords here. And there's 2 of them and you can rotate them, which I assume like gets rid of the old one. So this is one of those things that I'm going to go and clean up after I do TGIK. So we have the registry name and the login server and the username. Okay, so what we can do is we're going to do Docker login, and we can log in multiple times. And if we do this, what we're going to do is we're going to say the username is TGI Kubernetes. The password is this long random string. And then after the options, I can give the server, and the login server is tgikubernetes.azurecr.io. And it's giving you a warning that you don't want to pass passwords over the CLI. They have a way of doing it, because this can show up in history and stuff. So it's kind of generally a bad idea, but YOLO. So now I can do Docker images. I'm going to take this same image, Docker tag, and I'm going to tag it as tgikubernetes.azurecr.io/quard:1. So I've tagged it. Now I can do Docker push this thing here. And boom, we've pushed it to the registry. And if I look at this, let's see, does it? Oh, no, I just hit refresh on accident, and now it's going to reload the world. Okay. Oh, no, I wanted to scroll back. Okay, this is part of the problem of the horizontal scrolling, is that on the Mac, sometimes you actually navigate back when you mean to actually. So this is a container registry. How do I actually get the repositories under it? Okay, so you can see we have the quard repository. I didn't have to explicitly say create a repository. It automatically created when I pushed to it for the first time. And here you can see the tags. And if I scroll carefully without navigating, you can see it actually dumps the JSON. This is like nitty-gritty details of what happens with a container image. So you can actually see the 2 layers here and the size and the digest for those layers. And so the digest for the image ends up being the digest of this JSON, which includes the digest of the layers. So it's sort of that's kind of the Merkle tree-ness of this thing. So this is all up and running. Oh, one thing is that you saw by default with the Docker Hub, images were public, and they offer a bunch of images for free. You can host as many public images as you want there. With Azure, as far as I can figure, I couldn't find a way to actually do public images with Azure. So these things can only be accessed privately, I believe. So now we actually have an image up there. We have a name for the thing. And we have a way to log into the thing. So let's go ahead and we're going to create our Docker secret for the Azure registry here. And you can see that I have an old password that's left over there. Where it is, here we have access keys. So I can copy this thing again. I'm going to copy that in here. So here what we're doing is we're logging into tgikh.azurecr.io. Docker, the username is the same as the name of the registry, and then the password, and then the BS email. So we're going to go ahead and run this. Set up ACR secret. All right, so now we have a secret called ACR, and that's working just fine. Let's go ahead and modify. Let's do kubectl delete pod core-rd. Now we'll go through and we're going to modify our YAML here. So the first thing we want to do is copy and paste our image name here. Oh, we're going to change ImagePullPolicy to always, which means that like it's going to always try and pull a new one every time you launch. I'll leave the image pull secrets to the Docker Hub. And if I ran this right now, I wouldn't expect it to work. But one of the things that we can do is we're going to actually now attach the secret for ACR. We're going to do that via the service account. So it's another way of actually attaching this stuff. And so here we go. Let's see. So this is not, so this is things, so pull image from a private registry. This mentions how to actually do it on the pod, but it actually doesn't talk about how to do it on the service account. So Kubernetes image pull secret service account. Let's see if I can find the right thing. Yeah, so this is image pull secret. So yeah, so image pull secrets on the service account is just like what it is on the pod itself. So now what we can do is we can do kubectl. Okay, so in your book, the samples frequently use always pull. Is there any good reason to do that? So there's two reasons why you'd want to do always pull. So the first reason is, so there's a security reason and then there's a sort of sanity reason. So the sanity reason to use always pull is that it's very easy to be undisciplined about changing tags. And so if you're very disciplined and you only ever talk about things with respect to a unique tag and you never reassign that tag, then using pull if not present makes sense. And you'll get predictable behavior because that tag essentially becomes a immutable identifier based on your own processes for the image that you're talking to. If you're using latest, or if you're changing tags and updating things and sort of viewing tags as a mutable thing, then always pull will mean that you always get the latest version of that, and it'll help you prevent surprises when you're doing that. So like you should use always if you're ever doing sort of like a latest type of thing. Now the security reason to do this is if you're running multi-tenancy across namespaces and user A sets some image pull secrets and pulls down an image, and then user B comes in and they specify that same image, they don't have the image pull secrets because it's not in their namespace and they haven't referenced it, but it happens to already be sitting on the disk, so why not, right? You can actually then use it, and so if you're not careful, that becomes a way to have images, private images, leak across namespaces by just landing on the right node with the right image that happens to be cached on there. For that, there is an admission controller that you can configure, which will essentially ensure that you never use. Let's see, and we can look at that. Let's find that admission controller real quick. And so that will ensure. So. Is this the right one? Am I confused? Wait, okay. Always pull images. There we go. So this admission controller modifies every new pod to force the image pull policy to always. This is useful in multi-tenant clusters. So essentially what I said. So if you use this admission controller, then it'll essentially sort of whack everybody to be always pull. And so that ends up being a way to mitigate those security issues. Now, it turns out that it'll slow down startup time a little bit, but if the image is already pulled down, it'll essentially be a little bit of a no-op. It'll say, like, essentially be a permission check, make sure everything's up to date, and then you'll be off to the races. So, you know, if things are already cached, you're not going to be transmitting a lot of data. All right, so, okay, so now we have this. So we're going to do kube control edit service account default. When I go ahead and edit this here, what I can do is I can do image pull secrets name, and then we call this one ACR. Okay, I think that'll work. So now create. So now we'll create that pod. Oh, error image pull. What did I screw up? Oh, no. Unauthorized. So what did I do? I might have screwed up. Let's delete the pod. Let's edit the service account again. Oh, it got whacked from the service account. What did I screw up? I screwed up something there. Image pull secrets name. Did I not save it or something? Oh, now what is this? Oh, it got moved up there. Okay, whoa. All right, so that's working fine. Kube control. Left the whole old hub registry. ACR is still confused. Okay, so what did I... So I got that, kube control get SA default. This thing is name equals ACR. Kube control, did I screw up the ACR secret? No? ACR is still configured to fail. So Jim, do you have a clue for me here? What I'm doing wrong here? So this should actually be ACR. And then if I look at my QuarD pod, yeah, maybe the image pull secret, maybe this one's overriding. I would assume those got merged, but maybe they didn't. So let's go through, and we'll go through, and I deleted that. I don't know if you saw that. I deleted that from the pod YAML. And so Jim, you said, I thought you left the old login for Docker Hub and not Azure, maybe the old password. No, I was using a different script file there. YAML file says Docker HUD, should it be ACR? So what I was trying to do is actually have some image pull credentials on the pod and some on the service account. I was assuming those would get merged, but I think what happens is the image pull secrets on the pod end up clobbering the ones that are actually imported from the service account, so they take priority. So what I did then is actually go ahead and delete the image pull secrets from the pod, which means that it'll actually defer to the ones coming from the service account. So let's give that a try and see if that actually fixes it. So that's a subtlety that I hadn't known about. Yep. All right. So that's an interesting thing. So you either specify the image pull secrets that you want on the pod, or you specify it on the service account, but you can't specify sort of some secrets in one and some secrets on another. They don't actually merge those things together. So that's actually a good gotcha here. And is somewhat unexpected to me. I would expect those things to merge together, with maybe one taking precedence if they actually had the same key. All right, so that's great. So now we got Azure and Docker Hub down. So that's 2, and 2 to go. All right, so everything that we've seen so far, these are actually some of the easier cases. And the reason why they're easier is because they have long-term credentials that we can actually go ahead and store. And those long-term credentials are relatively easy to get. If I look at my notes here, one other point I want to make about ACR is that there's really two authentication mechanisms. There's this thing called an admin user on the registry. And so that is the method that we use. The other thing you can do is that you can create in the Azure Active Directory, you can create a service principal, and then you can give that access to your registry. And so if you're doing automation, if you have a lot of actors, if you want to actually be able to audit who's doing what, when, and where, then you want to do is actually give principals access to do that stuff natively. I'll post these notes in a gist that I'll link off of the that I'll link off of the show notes. But I'm not going to go through all this, but essentially what you can do is you can create one of these things, and then you essentially get a unique password for that service principal. And this can cross multiple registries. This can be used for other stuff in Azure. And you know, you can see all the Azure command line things to be able to do this stuff. So this is what's recommended if you're actually using this stuff in production. That admin user that we used here is really for sort of, you know, sort of single user type of thing. So if you're going to be using this stuff in Anger, you probably want to start checking out the service principal stuff, because that'll play with the rest of your IAM Active Directory stuff that's going on. Okay, so that's the last note on Azure. All right, so let's look at ECR next. So as far as I can figure, ECR is also just used for private images. There's a way to share these things cross accounts, but I don't think you can actually make it available to the public. And there's one registry per account per region. You know, it's pretty clear that these things are backed by S3 buckets. S3 buckets are a per region thing. And the name of the registry is going to be derived by the region that you're pointing it at, plus your account ID, plus some other random strings that I don't understand. Like ECR makes sense here, but I don't know what DKR stands for. Does anybody know what DKR stands for? I don't know, it's very confusing. Oops. And so if I go through here, and then if you're going to the console, because we'll do this stuff in the console, and if I type registry here, it actually, there is no tab dedicated to the registry. Instead, it's all through Elastic Container Service. DKR maybe for Docker? I don't know. Docker registry? Perhaps. Yeah. It must stand for that. So anyways, so you can go here, and if you don't have any ECS clusters or anything running, they have this sort of instantial, and you can sort of like say get started. And it says, what do you want to do? We want to store container images securely with ECR. And it leads you through this stuff, and it tells you what the repository URI is. And so let's create one called quard. Next step, and then it gives you, this is really nice because it gives you a whole bunch of stuff that you can just copy and paste. So this is sort of the cookbooky type of stuff. So the first thing you can do is you can call this ECR get login thing. And this spits out essentially a Docker login line along that automates a bunch of this stuff. So what you can do is you can do a val, and then, so let me, this get log. So I can do a val. Go ahead. Now I'm logged in. If I do cat .docker config.json, we're up and running. You can see that we have that here. I look at my keychain. We're logged in. We have that password. This thing here is like, that's the password. And this is obviously base64 encoded. Let's see what it says. I haven't done this yet. So echo. All right, so this is a JSON object that has a payload in it along with data key and expiration. So it's double base64 encoded. Oh wait, there's payload and then data key. So this is like sort of JOT-like. I don't know, let's see, base60. I haven't done this before, but I'm interested to see what's going on. Oh, and then this is some binary blobs that, was it? No, nothing interesting. I don't know. So this is some sort of binary blob that means something only to Amazon. Okay, so anyway, so this password that we have here is some long string that's used to authenticate you. One of the things that you'll notice here, and I hadn't noticed this before, is that there's an expiration. Um, this password, when you do this login for Amazon and you get these credentials are only good for 12 hours, I believe. And so what that means is that, like, I'm good, but I'm going to have to run this command every 12 hours if I'm doing stuff. And so, so there's the eval line that I did. And then the other thing is well, we'll go back here, but now I can do a Docker build, and then I do the tag, right? So, like, let's do, we'll copy this again. So we'll do Docker tag, and we end up with this really ugly long thing, /quard:1. So we'll do that, and then we'll do Docker push, and we'll push this thing, and we're pushed. That's great. Now, couple of things here, and so I'm a little off script here because my cluster where I tried to disable the cloud integration was busted. I can use this right now because I'm running on Amazon with the integration with Amazon. So let's just go ahead and give that a try here. So the image, if I go through and if I look at my pod YAML here, let's just go ahead and we'll actually do that. And then I believe if I create the pod, that'll create, and it's running already. So, so the reason that worked, so this is a private registry, the reason it worked is that I'm running on Amazon with a role on my nodes that gives me access to pull from all my registries. And the kubelet is configured to be able to use the AWS metadata server to get the authentication stuff necessary so it can pass that to Docker, and Docker can then go and actually download the images. So that's why this worked. Now, if you were running this, say, in Minikube, or you were running this in some other, like, cross-cloud type of situation, that wouldn't work for you because you don't have the AWS roles attached to your EC2 instances, so you can't do that stuff. Steve's saying, switch regions and push there. That's actually a good idea. So is this a standard COPS feature? Kind of. What really happens is COPS configures the cloud provider that's built into Kubernetes so that this stuff automatically works. So it's not a COPS feature. It's a AWS cloud provider for Kubernetes feature that COPS sets up by default. And our quick start also sets up that same stuff by default. To be fair, the folks who wrote COPS also wrote a bunch of the integration for Kubernetes into AWS, and so the lines between what's COPS and what's built into Kubernetes can sometimes be blurry. That's one of the things that I think we should probably work through SIG AWS to actually sort of create some brighter lines in terms of documenting that cloud provider and sort of where does COPS end and sort of core Kubernetes start. All right, so let's actually go and do what Steve said we should do here, because I think that's an awesome idea. What we'll go through is we're going to change, we're in Oregon now. Let's go ahead and we're going to change this to North Virginia, because that's definitely YOLO. We're going to create a repository called quard there. No, that'll work. Steve, it'll work cross region because it's all IAM. It's not actually per region. I don't think that'll work. I don't think that'll make a difference. If I switched accounts, it might work, but I don't want to switch accounts because I might flash some stuff that I didn't want to on the screen. Yeah, so I don't think switching regions will actually change anything there. Am I wrong? I don't know. All right, so a couple of other gotchas here. If I look at the container registry, we can see we have quard here. We can see we have image tag 1. It shows, all the image tags we have. Here's the digest. There's what's interesting though is that there's some really you can actually go through, and this actually integrates with IAM. And so instead of actually saying, hey, this account can pull any image that it wants, you can actually lock it down per service account in terms of how you're actually doing pulling. which is kind of interesting. There's lifecycle policies, which is deleting stuff over time under certain circumstances. So there's some interesting stuff going on there with ECR. Okay, so what we can do is, if I'm looking at, and I didn't create, I could do something like this, where the password, or like, let me go to ACR here, where this password is that thing that I get from calling AWS, what is it, AWS get login. I could call that, I could take that key, I could push that to my Kubernetes server, and I'd be off to the races, and everything would be great until like I try and go home, and the next day I try and push something in, or something fails in the middle of the night, and then all of a sudden the thing can't authenticate because these credentials expire after 12 hours. And so this will only be a problem if you're running off of Amazon, or if you're running on Amazon without the right credentials, the right cloud integration setup. So in that case, what you need to do is you need to actually update that image pull secret every 12 hours, or less than every 12 hours, to be able to get a new secret and be able to run that. That's kind of a pain. But luckily, Steve, who was just giving us some, in his previous job, because he's at Heptio with us now, in his previous job, he wrote this thing called registry-creds. And this works for both ECR and Google Registry, but actually you don't need it for the Google Registry, and we'll get over that. But like what this essentially does is it takes your AWS access key and secret key and the role that you might want to use. It then stores that as a secret, and then it uses that secret to go ahead and actually continually refresh as necessary the image pull secret that's necessary. I'm not going to, I wanted to be able to, well, it's available as a Minikube add-on, which is really, really nice. I'm not going to have enough time to really get into this. Best practices for this are probably to create a dedicated IAM user for this thing and give it very scoped permissions to just be able to get and pull images. And there's a policy to be able to do that. And then, so Steve said that, okay, so Kubernetes didn't used to actually automatically do the cross-region stuff as necessary, but now it does. Okay, so that's good to know. Thanks, Steve. All right, so you essentially create a secret with your Amazon credentials, and then this thing uses those things to essentially call that get login thing for you and rewrite the secret. And so again, I'll leave this in the show notes, but this is a great project if you want to access the Amazon registry outside of Amazon. And this will go and modify the image pull secret, and then so yeah. And it says, okay, so one caveat here, and there's a note here. This setup will set up credentials across all namespaces. And so probably PR is accepted. I don't know if Steve still has access to this thing. But if you want to, like right now, this would actually do it across all of your namespaces. It might be an interesting idea in a multi-tenant environment to be able to say which credentials gets provided to each namespace, but it'll go through and create a image pull secret for each of them. So yeah, so that's a really interesting project if you're using ECR outside of Amazon. Okay, let me go back to my notes. Okay, any last questions? So Steve says, yeah, there's a way to skip Kube's system so that it actually doesn't play with this, but PR is welcome. So yeah, it's an interesting sort of example of writing, a simple little controller that's sitting there and updating stuff. So I think that's a fun project. All right, so GCR. GCR is funky in its own way. And Steve says it was originally built before Kubernetes had the native ECR support. So this is only necessary now if you're running off of ECR. Before it was necessary whether you're running, if you're running off Amazon, now it's necessary regardless. Okay, so GCR. So let's look at Google now. So here's the Google Container Registry. Just like all the other things, there's a long list of services. This thing is buried under like tools /miscellaneous/kitchen sink called Container Registry Images. I've pinned that here. This is what we're looking at here. Now, the way that Google works is it's slightly different. It's in some ways it's more similar to Docker, right? So the thing that you log into is gcr.io. So that's essentially your registry. And then your repositories are actually, you have a sort of a sub namespace of the repository space. And so this image here, oh, let me go back to images because I don't have anything here. I don't have any images. But the thing that I'm going to go ahead and create, it'll be called gcr.io / TGI Kubernetes, which is the name of my project in Kubernetes, / QuarD. Okay, so let's go ahead and we'll do that. So Docker tag, and so it's going to be a little bit prettier than this. So do gcr.io / TGI Kubernetes / QuarD1. And now I need to push this. And there's three ways, count them, 3 ways to be able to actually authenticate and push. Well, maybe 2.5 ways. So the easiest thing I can do is if you have gcloud installed, you can do gcloud docker push this thing here. And so what this does is this sets up the credentials for Docker for just that run. And so it runs Docker with a special thing saying, here, I want you to use these credentials for this particular run. Now, all of the authentication in Google is actually built on top of OAuth. And so what happens here is when I run this, gcloud is actually injecting an OAuth access token as the authentication to Docker, as Docker actually calls into the registry to make things work. Those access tokens inside of Google are pretty short-lived. I think they last about 20 minutes. And so whereas the temporary credentials that Amazon was giving us was 12 hours, the temporary credentials that you're getting out of Google will last somewhere around 20 minutes. So obviously that's a lot shorter and that's a lot more difficult to deal with. And so some of the tricks of like, hey, 12 hours is enough for me to sort of log in locally, that doesn't really work great when you have to re-log in every 20 minutes. And so the first thing you can do is you can just call gcloud docker. Now, that works great unless you actually have other scripts that call Docker directly and you don't want to sort of like make those things deal with, you don't want to make those things deal with sort of special cases for calling gcloud docker. So along with gcloud, you can do gcloud components. There's a whole bunch of stuff that I have installed here. But the thing that we're talking about is this thing called Docker credential GCR. So if you do gcloud components install and then Docker credential GCR, components, if I spelled it right, it would work. So this installs a helper. And then I can go Docker credentials GCR. I run this and I can go configure Docker. And what this does is this actually goes in and it configures my config.json, so cat. And what it says is that, and it puts a bunch of like junk in here because like there's gcr.io is essentially sort of like the default way, but there's all different ways if you want to have like region specific versus cross region versus whatever. There's different GCR registries. So I'm not going to go into all the detail there. But one of the things that it says here is that there's this cred helper. And so this works a lot like the cred store, which says that anytime you need credentials for these things, actually call this program instead of actually just looking up stuff that's sitting here. So if you have the cred helper installed, now I can actually go ahead and I can do Docker, push. Instead of doing gcloud docker push, I can just do Docker, push. And this will go ahead and work also. And so that lets you use Docker like you used before. So that's the sort of like 2 half ways of doing this. So both of these are using OAuth under the covers. You can either do gcloud docker to do this, or you can install the credential helper and then just use regular old Docker. Now the other way to do this is to actually use a service account a GCP service account. Now, GCP service accounts are completely different beasts from Kubernetes service accounts, so I'll be very explicit. So what we can do is we can go ahead and we can create a GCP service account. For that, I can get long-term credentials and use that to actually log in. And so we'll talk about how to do that. And it's kind of weird because it's like I should be able, with my own user, be able to actually get a refresh token that maybe this thing knows how to use, but regardless, I'm not going to complain. In general, though, if you're going to be using these things long-term, installing it into a cluster, you don't want to use your personal credentials. You want to use some sort of shared credentials, and I think that applies whether you're using, Amazon, Google, or Azure. With any of those things, you want to create a dedicated user using the identity systems in those clouds. So let's go ahead and actually create a GCP service account. One other thing I'm going to show you. So this is a slight detour here. Is all the image layers for your Google Container Registry are actually stored in a Google Cloud Storage bucket. And that thing is called artifacts.projectname.appspot.com. I don't know why this is called this. I think this ends up getting shared in some ways with some of the App Engine stuff. It's really strange that this thing is actually called appspot.com, but this is the bucket that actually stores the layer information. So you can actually, if we click in here, we can actually see, like, here's the layers that we actually have pushed and dealt with. Actually, this thing, these are all different objects. So like if I look at this thing, it's going to download. Maybe if I show in Finder and like if I, just a second, let me open this. I'm off screen here, I know, but VS Code. Okay, so this is the image manifest. So this is both the image manifest and the layers that get stored there. So normally you'd think this would just be an implementation detail and you could ignore this, but it turns out that permissions on this bucket are the things that actually determine who can actually read those images and write to those images. And so there's two things that this is useful for, is that when we create this service account and we want to give that service account scoped permissions, we do it by giving it scope permissions on this particular bucket, which gives that service account permission to read all the images that are associated with this project. This is less granular than something that you can get with Amazon or Azure, which is kind of unfortunate. But one of the other things that we can do is that if you have the right voodoo, and you can actually set this bucket to be public. And if you set like public to the world, anybody can read it. And in doing so, you can actually create a host for public images. And so here at Heptio, we use GCR to say distribute public images for like Arc and Sonoboy and stuff like that. Google charges you just based on usage. It's really this bucket and sort of the Google Cloud Storage usage and storage fees versus the sort of per registry stuff that happens with Docker. And I believe Azure and Amazon are much more, usage-based versus repository-based also. So the downside, though, is that you can only have one set of permissions per project, so you can't actually scope these things down. So if you do create if you do make this thing public to the world, that's essentially that project only gets used for that thing. And so, so that's kind of annoying that you can't actually create multiple sort of subscopes underneath this stuff, or multiple ways to sort of lock this stuff down. Okay, so now let's go through and we're going to create a service account here. So I'm going to go through and, there's a whole bunch of stuff. You can see who has some permissions, but like I can go through service accounts. There we go. And I created one here called GCR Writer. I'm going to actually delete this right now. And now I'm going to create a new service account. I'll call it TGI Kubernetes GCR. And then there's like all these roles that you can actually give it. We're not going to give it any roles out the gate. And then we want to furnish a new private key. And then JSON, and then when I go ahead and I do this, it'll download this thing here. And then what I'm going to do is I'm going to copy that. to. So now I have that thing sitting here. If you look at this, you'll see that this actually has a private X509 certificate embedded in it. Again, flashing the credentials on the screen because YOLO. So now I need to go ahead and give this thing permission for my bucket. And so now I can go through and I can do storage, browser. I can click on this thing, and then I think I can do edit bucket permissions, and then I can do TGI. So this is that email looking thing is the name of the service account, and I select the role, and I think you need to give it storage admin. I was trying to like figure out what's going on here, but I think if I do that, we're good to go. And you can see, like, even though I deleted that other service account, it's still sort of like left over here when I was like pre-flighting some of this stuff, so we'll delete that. Okay, so now this thing has access to this bucket. All right, so let's log in locally with that service account. So what I'm gonna do here is I'm gonna do Docker. I'm gonna go through and I'm gonna remove this credential helper, the GCR credential helper before, because I don't want to use that. I want to now go through the service account here when I log in. And I can do Docker login. Okay, so I have to look this up because this stuff is like really confusing. Okay, so the user is called JSON key. And the password is called, it's cats. So this says I want to actually sort of load a file up and put that on the command line. We'll put it in quotes, TGI Kubernetes.json, and then https gcr.io. Oh, I screwed up. Okay, so wait, what did I do? Whenever I hand edit JSON, bad stuff happens. Oh, it ended up rewriting the whole file. Oh well, because I corrupted it. Okay, so that's good to know. If you hand edit that file and then you do a Docker login, Docker's like YOLO and like deletes it all, and then rewrites it all for you. So you may lose password and need to relog in if you screw that up. Okay. So this is working now. So now I can let's do a Docker push. Does that work? Layer already exists, boom, we're ready to go. So that went through the service account to do that Docker push versus not. Now I can do something similar and actually create a long-term GCR thing here where now, similar to everything that we've done before, where the username is this underscore JSON underscore key, and then the password is essentially that JSON document gets passed in as the password. It's kind of amazing this works, but it does. And then the server is gcr.io, even though I'm only going to be using a sub namespace of this. You can go ahead and do that. And you could actually then use this same service account cross projects too. So, service accounts can work cross projects. So now I can do, what did I call this? I called this setup GCR secrets. I have that. Now let's edit the service account, and we're gonna image pull secrets. We'll have both GCR and ACR going on here. Let's delete the pod. I need to change the pod so that instead of pulling from Amazon, I'm gonna pull from Google. So what was I was pushing? Here we go. And now I can do a create. Let me make sure I save that. All right, so we'll go ahead and create. And it's running already. Look at that. That's amazing. Describe it. You can see, yep, it pulled that image and it was able to do it. So here we used a GCP service account attached to a Kubernetes service account through an image pull secret to pull an image out of the private GCR registry into a cluster running in Amazon. So yeah, so that I think we've covered all 4 of them. I'm over time. I apologize. I'm getting longer and longer at these things. This seems kind of weird that we're doing all this stuff cross registries, but I think one of the nice things about this is that as we move to a more multi-cloud environment, being able to actually run the same thing across multiple different clouds ends up being really, really important. And especially if you're running stuff on-prem, you may still want to use a hosted registry for all the features that come along with that registry for the reliability. One of the things that I would love to explore maybe in a future TGIK is being able to self-host your own registry, which is obviously more involved than just using a registry that somebody else wrote for you. But hopefully this gives you all a good idea about how registry authentication happens with Kubernetes, how that relates to Docker, and some of these sort of ins and outs and gotchas across these different publicly hosted registries. One other note that I wanted to mention here before I go ahead and wrap up, and this again, this is in my notes here. There was a bug in Kubernetes 1.9.0. So Docker used to store all this stuff in a file called .dockerconfig, and this is like a long time ago. So this would actually be a single dot file under your root directory. And then over time, at some point, at some point, let me look at this PR here and pull this up. Why is that pulling up down there? There we go. So this was 2015. So we're like, almost 3 years ago now. 3 years ago, things migrated from Docker config to .docker/config.json. But it was only in the latest. And so what happened is that when you create the secret, there were actually 2 types of secrets for ImagePull. There was one for this old format of Docker config, and then there's another one for the new format of Docker config. And only in 1.9 did the default for kubectl, when it creates the secret, it changed over to actually creating secrets of the new type, right? Because it's like ancient history, that old one. I mean, 3 years ago. Wow. And so, but when that was first done, there was a bug where it fixed some of the stuff up and not some of the other stuff. So if you have a kubectl 1.9.0, it has that bug, and it'll actually create ImagePull secrets that are not compatible with pretty much anything because they changed the format but not the type. So that's fixed in 1.9.1. So make sure that if you're doing this stuff, you're either running the old stuff, kubectl 1.8, or you're running the new stuff, which is kubectl 1.9.1 or above. So Lamati says, are there any guides out there discussing which versions of Docker work best with a given release of Kubernetes? I don't know where it's written down, but what I can tell you is that SIG-Node does actually do testing of different Docker versions. I don't know where this stuff actually gets written down. It's in the, okay, I'm going to do some code spelunking now. Give me a second here. Let's do 17, what was it, latest Docker version? Let's see, Docker, let's just search for Docker version here. I believe, yeah, so here what you can see is, here's essentially the validate Docker info. And so this is actually the end-to-end test to actually validate things. So CE, do they actually have, and I believe Docker config free version, I'm trying to figure out. Okay, so if it's a new version one, there's actually info, there's a regex for it. Okay, so it's got to be, so up to 1703 has been validated in the latest versions. And so there's a regex to try and sort of pull this stuff out. If not, it's any of the older versions than that. I believe there's like new and old versions. So you can read this code and try and figure it out. This test runs as part of the kubeadmin pre-flight. And so kubeadmin will actually go through and make sure that you're running a version of Docker that has been, and the graph driver that it has been tested by Signode. So yeah, it's not written out any place that I've seen that is super consumable, unfortunately. All right, so that's not a very satisfying answer for that. But thank you everybody for taking the time, hanging out with me on a Friday afternoon, Friday night, Saturday morning, whatever time it is for you. I appreciate it, and have a great weekend. And I'll see you all next week.